I'm Ahmed, and in this session, we will have a quick tour of how we can use multi-class performance measure. Regarding the selection of performance measure, we already have done in the last sessions how we can select best performance measure with respect to our problem statement. So in this session, we will see how we can implement them, and it's quite easy regarding implementation. If you will see the documentation regarding Scikit-Learn metrics, there are it is providing F1 score, recall score, precision score, and in the documentation you will see that for recall score there is a parameter average. Whatever average you have decided, you can just pass the value here, and you can use that average. In the case of precision score, again there is a parameter average you can use. In the case of F1, there is also an average parameter. So regarding implementation, it's quite easy, uh, but how we can select the best performance measure, it's a main part. Okay, so in this session, we will not obtain some optimal model. As you know, performance measure is not for the case of to evaluate our model, how good our model is. Performance measure we can use for other purposes like model selection or for parameter tuning. So in this session, we will have a look how we can use performance measure. We will not actually obtain some optimal model. We will have a look how we can use them. Okay, so by just a simple example. So there are some of the important libraries I am going to import here, and this dataset that we have discussed also in the theoretical part I am using here. So here I am creating data frame in which there are multiple columns. There are just two columns. In cut column is dependent column, target column, and color and clarity are two categorical columns. So and other columns are numerical. And there is just one this unnamed zero column. It's like a some index column, I think. So we will drop that. You can see here there are four classes we have: ideal, premium, good, and fair. In the case color and clarity, there are some categories. So we will convert them into numerical one hot encoding by using pandas.get dummies. Okay, so now we have here 22 columns instead of just these columns. So again we will drop that column unnamed. Now we have just 21 columns. So we will see the info. In the info you can see just one column which is cut category. Our target column is categorical column, and all the other columns are numerical, and there is no null values. And about 54,000 data samples we have in that data set. Okay, so we will not to go towards the part of VDA and pre-processing to keep that lecture uh, just to focus on the performance measure, so that we will not go toward the part of data analysis. Okay, so I am directly jumping towards the splitting of my data set into dependent and independent variables. And here you can see in the value count, you can see the frequency regarding all the classes. Like here you can see about 40% of the samples in our actual data belonging to ideal class, and there are just approximately 3% samples belong to fair class. And you know, when we are having imbalanced data set, and we will train some model on imbalanced data set, we will obtain some unbalanced model. Okay, because it has seen less number of samples regarding to the class which has less number of sample uh, in actual data set during its training process. So it will be less sure to predict that class in the predictions. Okay, so here I am going to split my actual data into training and test part with the default ratio, which is train test split usually have 75% data for the training part and 25% for the test data set. Here I am going to use a technique of stratified sampling. Stratified sampling, it actually do in that way. Uh, Split the dataset with respect to each class. Like 75% of the data samples of ideal class will go towards in the training part, 75% of good, 75 of premium, 75 of fair. With respect to each class, it will split the data, and 75% of each class will be in the training part, and 25% of each class will be in the test data set. So that the same type of data we will use for the training part, and same type of data we will use for evaluate our model. So for that purpose, I am using a stratified sampling. You can see from here this image, you can get a clear idea. Like there are this is a population in which there are three categories. Uh, Usually a category called as a stratum. So stratum 1, stratum 2, and stratum 3. And when you will have to select some random samples from each stratum, so you will get these samples. So here you can see two samples from each stratum we have in sample data. Okay, you are not directly sampling or get randomly select six samples out of all uh, given population. You first divide that into the given stratums, okay, according to the categories in that population. So the same technique I am using here, and you can see in the training data set, there are again 40% of training data points belong to ideal class, and 3% belong to the fair class. And in the same the ratio is maintained in the test data set also. You can see here 40% belong to ideal class and 3% of belong to fair class. Okay, now we will define some example that we will discuss here. Let's say for a while, um, we are curious about the class which have less frequency in actual data, the class fair class. We are curious, let's say, and now we will see about which error we are curious of fair, like predicting fair as not fair, or predicting not fair as fair diamond. Okay, so about which error we are more conscious. Let's say we are conscious about the error predicting some uh, fair diamond as a not fair diamond, let's say. And for a while you can say fair is the most expensive diamond out of all diamonds. So we are curious about the class fair. This is our problem statement, you can understand in that way. And we are curious about the false negative of fair. So we want such type of model which should have less or fast negative regarding to fair class, or you can say which should have high recall regarding to fair class. As you know, fair class already have less number of samples, so our model that we trained on our data set will be imbalanced and will be less sure about the fair class because it has seen less number of samples during its training process. So for that purpose we are going to use macro average, so that if instead of weighted average recall, we are using our macro average to give the equal weight to each class in the overall score. Okay, so now we want, so that we can have such type of model which will be good on each class irrespective of their frequencies in the actual data. So we want such type of model which is which have high macro average recall. So we have selected macro average recall as our performance measure for multi-class case. Okay, so there are a lot of classifiers actually available, and I am just considering six classifiers you just to give you an idea how we can do model selection. So these six classifiers I am importing from Scikit-Learn, and here I am also to evaluating them. I am using here cross-val score, also from the Scikit-Learn. So there, don't worry about the other classifiers. You just till now you have idea about the logistic regression. We have studied that, and other classifiers in the coming modules we will have a look on them and will learn in detail. But for now, just consider there are we have about six classifiers, and we will test which classifier will give high macro recall score. Okay, so there are six classifier, and I have created here a list of classifiers, and I will uh, pass, I will run a loop, and I will test each model one by one. Okay, each classifier one by one. So here I am using a cross val score. You know about the cross validation score. It split your data set into five parts, and each let's say into five parts, and first four part in and train your model five times and evaluate your model five times if you have mentioned here CV is equal to 5. Okay, well it depends upon the that number how many times you want to do that process. Okay, each model will be will follow that pattern. You will have a training data set which will be separated into here CV is equal to 5. So model data training data or data set that you are passing here will be split into 5 parts. First 4 parts will be used as a training process, and fifth part will be used as a evaluation of our model. Second, in the second iteration, the let's say second last part will be used as a test for the testing of the model, and other 4 parts will be used as a training of the model. In the same way, the process will be carried out for all the 5 parts. Okay, so in that way, our after the same model on the have 5 scores against each you can say split. So the average of that score we will use here to evaluate what how good our model is actually. Okay, so I hope you already know about the cross validation process. So we will here evaluate our 6 models. We have trained that 6 model and evaluated these 6 classifiers. Okay, and here you can see out of all classifiers, backing classifier is giving about 81.48% macro average recall, which is highest among of all classifiers. Okay, but till now we have no idea about that classifier, so we will not continue with that classifier. We will here logistic regression is giving very bad macro average recall about 36%. But till now we have studied logistic regression and, as our classifier, so we will continue our logistic regression. Okay, so for a while consider that logistic regression is giving highest score among of all the classifiers that we have tested in. Okay, so because we have no idea about other classifiers parameters, so for now you can consider that you your logistic regression is giving you high score here. Okay, so now we will do hyperparameter tuning, means we will select the best parameter values for that logistic regression. So here we will see what solver should be best for our case, what penalty we should use, what scheme of multiclass we should use here. Okay, so there will be 5 into 3 into 2, or there will be 13 combination of these 3 parameters will be used here. And each time you will pass one combination to the logistic regression. You will train a logistic regression with having one combination of values, and then that logistic regression will give you some score. In that way, all the 30 against all the 30 combinations, you will train 30 logistic regressors, and all 30 logistic regressors will give you some score. Out of all scores which will give you best score, high score will be considered as a having good parameter values. In that way you actually carry out the process. Okay, again we will use the same macro average recall here. Okay, I am going for hyperparameter tuning grid search CV I am going to use here. And here, I hope you already know about the grid search CV. I am passing a logistic regression parameters in the form of dictionary, scoring, recall, macro, and in the a lot of modules of Scikit-Learn, there is available scoring parameter, and you can pass here the strings. Like if you are, if I will show you here. Here you can see that these type of strings, and each string have some purpose. Like if you will pass a simple f1, it will calculate simple f1. If you will pass the f1 micro, f1 macro, f1 weighted, whatever string according to your requirement, you can pass the parameter value of scoring. Okay, so here I have selected that recall macro is my best measure. So I am going to pass here recall macro, and I want to evaluate my logistic regression with different parameter values with respect to recall macro score. Okay, so here there are 13 models, 30. Okay, so again I am going to use a cross validation is equal to 5. So there will be 30 candidates, and 30 into 5 there will be 150 fits total. Okay, and again 150 fits, and there will be 150 scores against each trained model. So the average of 5 logistic regressions will be a score. Okay, and if you will see that from here, I will show you. Okay, anything here? Okay, so n jobs is equal to -1 just for the sake of using all the processes or cores when we will run that cell, and verbose to see the information during that running of that grid search, fitting of that grid search CV. Okay, so here I am going to see my grid search CV results in the form of data frame. So here you can see there are a lot of and values, missing values. I will give you the reason why these are missing values. And here you can see against each sublet you have some score, like um, uh, here is a combination of let's say first time this grid search CV has tried the combination where the multi-class is OVR, penalty L1, solver is linear. Okay, and it has split your data set into 5 parts. First time it has used first 4 parts as a training process and fifth part as a testing process, and which has given you 0.51 macro recall. In the same way, second time it has used the second last part as a testing part, and other 4 parts it has used for the training part of that. Okay, in the same way it has iterate the same combination for 5 times, and then it has taken the average score. Okay, in that way it has calculated, and out of all the average scores, out of all the scores, which combination will give us the best average score will be considered as our best combination. Like this is giving a best score, it also has given rank test score. Okay, so due to rank test score we can see here it is giving us the 1 2 3 4 5, and this is the average score 0.59. This is the highest score out of all the parameters we have tried, and these parameters are Newton CG, penalty none, and multi-class is OVR, giving us the best score, best recall, macro recall out of all the combinations. Now we will see why there are missing values. If you will recall your logistic regression class, you can see that we have discussed that table, that there are some compatibilities, like in the case of multinomial, multi-class is equal to multinomial and plus L2 penalty. You can use all the solvers except the linear. Okay, and in this way you can see that instead of 30 combination we have tried here 1 2 3 4, we have not tried elastic net. So 1 2 3 4, yes, in the case of none, we have tried 4 classifiers. In the case of OVR plus L1 we have tried just 2 solvers. In the case of multinomial plus L1 we can use just one solver, which is SAGA. In the case of OVR L2 we can use all the 5 solvers, and in the case of multinomial plus L2 penalty we can use 4 solvers. So 4 plus 5 9 plus 1 10 plus 2 12, and plus 4 16. Out of 13 model, 30 models we have tried here, 30 combinations, and there will be 14 combinations that are incompatible to each other due to different parameter values, and there is some technical issues, and that's why we have discussed that table. Okay, if you can recall that lecture. So all the other 16 will have some scores here, and out of these 16 we have here figure out that mm, this combination is giving the best score, where the multi-class is equal OVR, penalty none, solver Newton CG, and best score is 0.59. Okay, 0.59 macro recall. It's not actually so good score, but here you can see we, out of all the combinations that we have tried here, this combination is giving the best score, or you can say maximum score. Okay, and this combination. Okay, and there is a lot of detail if you want to see that. Again, the splits, their mean score, their standard deviation, everything regarding their processing time is also mentioned here. Their training time, mean fit time, standard fit time, everything, standard deviation. Okay, so till now you also have uh, understanding regarding the selection of performance measure. First, you have selected your performance measure with respect to the required um, problem statement, or required with respect to requirement of your project. Like here, for example, we have selected that macro average recall will be best performance measure for our case. By using that performance measure, we have selected the best model. As we have no idea about the other classifiers, so we have carried out our the model of logistic regression, as it is not good in our this example or this project, but for the sake of example we have considered that logistic regression is the best among of all classifiers. Then to find out the best parameter values for the logistic regression, we again have used the grid search CV, and we have evaluated our logistic regression with different parameter values, uh, and we have seen that which parameter value is giving best score, best macro average recall. Then we have figured out that uh, this combination of multi-class OVR, 99 and solver Newton CG giving the best score out of all. Now we will go towards the part of model building. That type of in that way the process is actually carried out. Okay, so first model selection. What will be the model? What will be the best model in our case, in our according to the project? What is the best parameter values according to the requirement? And then we will go towards the part of model building. Now we have selected that logistic regression is our best model. Uh, these parameters values are our best parameter values. Now we have trained our logistic regression on the actual training data set. Now we are going to see the predictions of that logistic regression that we have trained. Okay, now you can see in the form of confusion matrix, and instead we will see a classification report. So classification report also available from the Scikit-Learn.matrix. You can import, and it's quite easy to use. Just pass the true values and the predictions, and it will generate a whole report, very fancy report. You can see here from against each class is it has calculated the precision recall F1 score. It also has provided the information regarding the count of each class in the actual data set in actual y test. Okay, and here it is also have calculated the averaging, like macro average of precision, micro average of recall, macro average F1 score, and weighted average precision, weighted average recall, and weighted average F1 score. And regarding micro average, you know, micro average of precision, recall, F1 is actually equal to accuracy, so that's why it's they have mentioned here accuracy, and it is 0.70. And you already know that accuracy and weighted average recall are also both are equal, so you can see from here also 0.7 and 0.7. Okay, and as I told, in the case of macro averaging, uh, the all the classes, score of all the classes have equal impact, and you can see from here, like if you consider macro recall, so the fair class have the recall of fair class is bad out of all the classes, and due to having equal weight, you can see that your overall macro average is low as compared to weighted average, because in the weighted average you have given the lower weight to that fair class because of their lower frequency in the actual data, and here weighted average is high than the macro average. But in the case of precision, you can see macro average precision is high because here fair class has high precision, and as macro average usually give equivalent to each class. So due to now here this fair class precision of fair class have good impact on the overall score. But as weighted average has given the less weight uh, to the precision of air class due to its less frequency, so it is less as compared to macro average. So in that way you can also interpret that classification report. Now this session is not just to not for the sake of getting optimal model, because we have not here in this session we have not obtained some optimal model. We have carried out just the process how we can use our performance measure. Okay, first of all, whenever you have a problem statement, you have to select the performance measure so that you can use for the purposes like a selection of model like hyperparameter tuning, and also you can see use that performance measure to evaluate your model also. So this was about the just practical tour of implementation of performance measure. It's quite easy, and In the next sessions, in the next modules, we will also study the different classifiers like random forest and decision trees, and regarding the model selection and hyperparameter tuning. In the coming modules, we will also have a look on these part, how we can use some more advanced techniques to do hyperparameter tuning, to do model selection. So in the coming modules, we will study that part in the detail. But that lecture was just for the give you an idea of how you can use performance measure for that purposes. Okay, so best wishes for now. Hopefully, we will meet in the next module. For now, thank you.